Yes.
I changed the next example. It's not the same as when you have your notes. I think your notes say x minus 3 times x plus 4. It should say 2x minus 3. You need to give me a big old foam middle finger for this. But I was sitting down at my desk, I take my middle finger and cover up a factor. If I cover up one of my factors, what's it say about x plus 4? 0. So x plus 4 is 0, according to the zero product rule, or what's it say about 2x minus 3? But it's a 0. One or both of those are true. So let's do the easy one first. If x plus 4 is 0, what does x have to be?
Negative 4.
Negative 4. 99% of the student body can do those. For some reason, only about 3/4 of the student body can do 2x minus 3 is 0. It blows my mind every year. To solve 2x minus 3 is 0, what do you add to both sides? 3. 2x is 3. And divide by what?
2.
So what's my x value?
3 over
3 over 2. So x is 3/2, or x is negative 4. It's not a hard concept. One of the numbers actually changed value as left parentheses, but in both cases, what happened to their signs? Switch. That is a golden rule in algebra. If you leave parentheses with a number, the sign will change. Always happens. So that's an example of zero product rule, as easy as you can make it. Next example is pretty easy. It is a zero product rule. 9u squared equals 3u, but it has a problem. What is it not equal to?
0.
Obviously, if you use the zero product rule, you have to equal what? So how do you fix that? There you go. Subtract your 3u. Move your 3u, whatever you want to say. If you do that, you'll have 9u squared minus 3u. And the good news is you're now equal to 0. But you still can't use the zero product rule. What does product mean? Multiplication. This is subtraction. So you focus on the first amendment of mathematics. Pull it. Pull you. Pull a little more than you. Sometimes you need to pull all of it. This is one of those cases. If you pull a 3u from a 9u squared, what remains? 3u. Pull a 3u from a negative 3u, what remains? A negative 1. Think about your distributive property. If you could redistribute that 3u when you got the original back in factory credit. Now can you use zero product property? Yes. There's two things multiplied together. One of my factors is 3u, and what does it have to equal? It has to equal 0. Remember? What's my other factor?
3 minus 1.
And it has to equal 0. Every person I've called on has missed this one today. 3u is 0. Oh, you've never called on anybody. You suck.
No way anybody here.
Oh, yeah. Oh, yeah. I've heard negative 3, I've heard 3, I've heard 1.
True. Where do you get one?
Ross thing, you know.
See, asking kids like Ross. True.
You has to be 0, isn't it? 3 times 0 is 1. 1. Now, I would love for you guys to get to the point where you can do 2 steps in equations, and a lot of you can. If 3u minus 1 is nothing, what is the u value? It says 1/3. What did he do?
Add the 1. Add the 1 and then
Divide by 3. That's not hard to do. I realize that not everybody can. So we move the 1 over. 3u is 1. Divide by the 3, and u is 1/3. So there's our 2u values. We're either 0 or 1/3. that question that's in your notes next is actually from yesterday. You just didn't know how to solve yesterday. Now you do. Any issues on this that we need to talk about? All right, we have a modeling with quadratics. You should probably draw the rectangles. Yeah. You probably should. It says a town has a small park that measures 60 by 40 meters as shown. The town wishes to double the area of the park by expanding into unused land, adding X meters to the length and the width. What are the new dimensions of the park? What do you think the new dimensions are if you're going to double the area? I wish I was young and dumb again. It's not. It doesn't work that way. It's not going to be 80 and 120, kids. It's not. All right, so let's think about what the town's doing. They're going to double the area. What was the old area? 240. 2,400. 40 times 60 is 4 times 6. Add how many zeros? 2. It's 2,400. New area has to be 4,800 because we're going to double it. All right. If you can read, you will see here that we add X to both the length and the width. So the old length was 60. What's the new length? Oh, no, you just multiplied them together. 60X is there you go. It says add. It doesn't say multiply. It says add. What's the new width? 40 plus. You guys will have a form quiz tomorrow, and sadly 15 juniors and a couple of seniors will not write down the correct thing for area of a rectangle. Like, I know I'm being recorded here, but none of my students are in special ed. Juniors? How many years you been in school? 12? How do you find the area of a rectangle? Length times width. And I swear 15 kids will miss that tomorrow. They'll write something stupid like 2 pi r down. I've seen 1/2 pi d. It's a rectangle. Why are you thinking about pi? And diameter, or diagonal. I can buy diagonal. There are formulas involved diagonals. But its area is length times width. So what do we know about our rectangle?
Area equals 4,800.
Area is 4,800.
60 plus X times 40 plus X equals 40.
We can use substitution property. Of course, some of you guys can brute force your way to this answer without doing this. I get that. But you're in algebra 2. You're supposed to learn how to do things when things are easy. So it's hard. You can't brute force your way to an answer. All right, that's what we have. What you got say on the right hand side? What? What? Your gut should say you fall on the right hand side. It's something you can do, isn't it? 60 times 40? 2,400. 60 times X? 60X. You're done with the 60. What do you move on to? X times 40?
48.
X times X. What would you like to do on your next line?
Add the 60X to
Combine like terms. That's the general deal. I'm going to move the X squared out front on that part because you're kind of learning how to factor, and what you've done in factoring so far, where have the X's always been? The X squared's been first and the X's have been in the middle, right? That's kind of how it goes. We are trying to use a zero product property today. What should this thing be equal to? 0. So what's the next thing to do? Subtract 4,800. 0 is x squared plus 100x. Take away what? 2400. To use the zero product property, you have to have products, not sums and differences.
Yep.
So, factor. No factor. What's it take to make an x squared? It's an x and x, so you're halfway done. How about 2400? Yeah, what are factors of 2400? Try 1640. Oh, guessing check. So the interior is going to make 60x, and the exterior is going to make 40x. And I guess if they were both positive, it would work, wouldn't it? No.
Okay.
It's negative 2400.
Oh, yeah.
1640 won't work, do they? Now, of course, we're talking about factors 2400. You actually think I'm playing with 2400 in my head?
124.
I'm playing with 24. All right. What'd you say?
120.
120 and 20. I'm playing with 24, 12 and 2. Probably what he's doing too. Or maybe not. I don't know.
Huh? What do you mean by playing with 24?
When you're thinking about factors 2400, focus
Oh, yeah.
on 24. Focus on 24. So the other suggestion was 20 and 120. The outside makes 120. The inside makes 20. And what's our goal to get to? 100. Subtract 20. Add 120. That'll work. It's a nice airplane, Tom. Does it fly? That's a nice airplane. Does it fly? You should throw it at somebody and find out. All right, now can we hit this thing with a zero product rule? What are your two x values? So x is everybody understand what just happened? Take each factor, set it equal to 0. All right. Which one of those works? 20 works. Now, and this, when you got more notes to take here, sadly. If you throw a 20 at this thing, we get 60 and 80, right? All right, so that's the actual dimensions here. The length is 60. Sorry, the length is 80, and the width is 60. What happens if you throw the negative 120 in? Maybe negative 80 and negative 60? Do those numbers actually still work? Actually, they do. They work on paper. I want you guys to understand that. They work on paper, but they don't work in reality. Do you get that? So, like I said, you're about to learn something here. You actually have a vocabulary word we use quite a bit. Extraneous solutions. You don't understand that SOL is the abbreviation I'm choosing for solution. You are literally SOL. Extraneous solution is a solution that works on paper, but not reality. That's all it is. Works on paper, not reality. Because it does work on paper. You still get 4800. But I have no idea what negative length and negative width are. I haven't done enough drugs in my life to figure that out. Maybe one day you will. So we have a real solution. It's 20. And then we have an extraneous solution. It's not imaginary, it's just extraneous. Equal to negative 120. Any issues with that question, other than it's apparently a lot of work? Kids say, that's a lot of work. That's not a lot of work. That's not a lot of work. That was quicker than changing oil in your car. Wasn't it? I mean, that's not a lot of work. If you change the oil in your car. Yeah, you claim to be smart. That's easy. All right, moving on. Factoring where the leading term is not 1. That's what this is. You can pay attention to all that stuff in red if you want. I'm going to throw it all away. I like guess and check. So the first thing you want to try and create is 5x squared. There's only one way to do that. What's it take to create 5x squared?
5x and x.
5x and x. Almost everybody knows that by now. You have to lead with a 5x and x. And you understand that because you know how to FOIL. If you don't know how to FOIL, you probably don't have a clue what's going on. That's the honest truth. You can figure out how to FOIL in a hurry. Oh, is that not in your notes or something, Michael? That's not in your notes.
Tripping. Number 4. Bottom left.
Yeah, look at his and his.
Wow. Don't mess them up, Mr. Milbrath.
No, theirs is the same on the front as yours is back. You guys didn't notice yours is the same on the front and the back? I'll be messed yours up somewhere. I have no idea how that is. Yeah, yours is the same on the front as the back. I don't know how that happened. Everybody else's notes right? I have no idea how that happened. Okay, cool. We got our 5x squared created. What do you want to create next? 6. So we focus on this guy first, then we focus on that guy next. How do you want to make a 6? 2 and 3. That's what I heard. Yes, and then you what? Check. I kind of wish more kids would miss this one, but they never do. That's a 2x, and that's a 15x. Can you get to 17?
Yeah, both of them negative.
Both of them negative. And is a negative 2 times a negative 3 still positive 6? Then check. It's good to go. So it equal to 0? Hit it with your zero product property. What must 5x minus 2 equal? It must equal 0. What must x minus 3 equal? 0. All right. Katie, if 5x minus 2 is 0, what's x? 2/5. Tom, if x minus 3 is 0, what's x? 3. Does anyone need me to explain the whole 5x minus 2? Because I know that's a problem for some. Don't speak to everybody. I heard yourself. All right, moving on. What's up with the first one? It's not set equal to 0. It's not in standard form. So what do you want to do with it? Subtract 3x. Good. Your gut was right on that one. 6x squared. Take away 3x. Take away 63 must equal 0. Anything else you see? You're just going to go ahead and start factoring that?
Okay. You can all simplify.
Simplify it. All three terms. Now, you don't have to do this. You don't. But what it does is it makes the factoring easier. If you pull a 3, you'll have 3 times 2x squared minus x minus 21 equal to 0. Because if you had 6x squared, you would have to think about 6x and x or 3x and 2x. Now it's locked in place. How do you create 2x squared? 2 and 1. 2x and a singular x. And instead of thinking about 63, which is a whole bunch of factors, it's just 21, which doesn't have that many. And there's an obvious pair that'll probably work that comes straight to your head. 7 and 3. You want to do it in the order that you said it. Actually, we do. You said 7 and 3, and that's the perfect order. Because the inside makes how many x's? 7. The outside makes how many? And the goal is to get where? -1. So, -7 plus 6. All right. How many factors that thing have? We just factored it. How many factors did it have? At 3. 3 is a factor, isn't it? How many of those factors have unknowns? 2. Those are the only ones that we actually care about. The only factors that we actually have to solve are the ones with unknowns. It wouldn't make sense to write on a piece of paper 3 equals 0, would it? Which is not true. So what are the 2 things I should write on a piece of paper? 2x minus 7 is 0, or x plus 3 is 0. Those are pretty easy to do. If 2x minus 7 is 0, term below, what's x? If 2x minus 7 is 0, what's x? Okay. What's the first step, Turnbull? 7 over 2. Add 7, divide by 2. Can't just live, breathe, eat, sleep, football. Easy factor. If x plus 3 is 0. X plus 3 is 0. X is -3. What's the other factor of that problem? Are you asking what the next problem is? It's not on your notes. Put it on your notes. Factoring will be with you pretty much every day from here on out. I know. It's fun.
Oh, yeah.
It'll be your favorite F word. Instead of you saying FUC every day when you walk into my classroom, you're like, factor! All right, we got 12x squared equals 28x plus 5. What would y'all like to do? I'm glad you said that, because that's wrong. So Daniel said something that a lot of kids do. It's easier to move 12x squared as opposed to the other two, isn't it? Just a little itty bit easier. But the problem is, if you move that 12x squared around, what happens to its sign? It becomes negative. It's far easier to factor if the leading term is positive. Never, ever make the x squared term negative. Always keep x squared positive. I'll put that in your notes because it's kind of a big deal. But you guys will do you, and you'll wonder why things are hard. But you always keep x squared positive. If you're presented a case where it's not positive, guess what you do? You make it positive somehow. Otherwise, the factoring will be harder. So I think we should probably shift everything to the left. If we shift everything to the left, what do we have?
12x squared minus 28x minus 5.
And we got lots of choices now. There's how many ways to make a 12 when you think about its factors? 3. You got 1 and 12, 2 and 6, 3 and 4. Pick a pair.
3 and 4.
3 and 4. I'm okay with that. 3x, 4x. Some ways to make 5. 5 and 1. Let's just do this what Chris said. Maybe we'll miss it. We haven't missed one yet, have we? Doesn't hurt y'all to see something getting missed. Oh yeah, we're gonna miss this one. That sounds good. 5 times 4?
12x.
20.
1.
1 times 3?
3.
3. Another, what's the goal to get to? Is that gonna do it?
No.
No. It's called guessing.
Dang, Chris.
6 and ain't no place.
6 and 2.
Well, we could have changed the order. I don't know that would have done any good. But we've done 1 and 5. Well, look, I'm glad that you get this. But kids need to see that if the first order doesn't work, what can you do? Switch it around. That's 15x and that's 4x. Will that do it? So what you just did is you exhausted that parent. You exhausted the 3x and 4x. Didn't exhaust 1 and 5. They're set in stone, aren't they? You had no choice. But 3x and 4x will work. So what's another parent? 6x and 2. That is the correct parent. Actually, in that order that's listed. The outside terms, 6x and 5, what's it make? 30. How about the inside parent? 2. What's the goal again? Negative 28.
So that's going to be a negative 6.
Going to be negative 5, positive 1. 5 has to be negative because it was used to create the 30. 1 has to be positive because it was used to create the 2. And we're going to skip the zero product property on this one because we've got enough of those. Let's skip the U-try. You got a whole bunch to do tomorrow. We do. What's it say on the board?
Factoring back.
Did you think I was going to do it? No, I already know how to factor. Way better than y'all. So I don't need practice. All right, let's look at the first one up here. Do you even have that in your notes? 3y times y minus 5 is negative 12. What do you want to do? Distributive property, of course. Always do the distributive property if you see it. Well, not always. Usually you do the distributive property if you see it. 3y to the second minus 15y is negative 12. Cameron, anything else wrong with it? Add 12. For a second there, you look like your brother. I loved your brother, but him and math, they were like oil and water. They don't mix. He tried, though. He did all right. Oh, you guys got saved by the bell, didn't you? I don't even remember. Pull a 3.
Oh, you pulled the 3, yeah.
Of course I would.
I've got 3y minus 3 and y minus 4. Which work?
I don't even remember, but I would have pulled the 3. And then it would have been y minus 1, y minus 4. Yep.
I just don't immediately see factor out.
Not yet.
I don't think I probably will.
Yes, you will. You will.